Okay, so this is 9-5, functions and their inverses. And I'm not going to stay long on any one page because you can always pause it if you need more time to copy something down, or you can rewind if you need to hear something again. So we're going to start off with talking about pictorially how you can tell if something is an inverse or not, and you do that by the horizontal line test. So, in past subjects you find that the vertical line test tells you whether something is a function or not. The horizontal line test tells you whether the inverse of what you're seeing is a function. So I have given you two pictures here. The first one, if you notice, if you draw a horizontal line through that, it makes contact with your graph twice. If it makes contact more than once, then it's not a function. Okay? On this graph, if you draw the horizontal line, it only makes contact with your graph this one time. So that means that the inverse is a function. So you have two ways to do that pictorially. Okay? So there are other ways to do this. If you want to determine whether two things are inverses, what you can do is you can use compositions. So if you do f of g of x and you do g of f of x, and each of those equals x, then that means they are inverse functions. So what we're going to do is we're going to start off by doing f of g of x. Okay? So remember, what that means is that we are going to take g of x and we're going to plug that into the f function. So if you will recall, whatever is out here is what we're going to write down. So I'm going to write down the f function, but in place of this x right here, I'm going to put parentheses. All right? And in the parentheses, I'm going to put in the g of x function, which is over here. So I'm going to plug in 1/2 x minus 4. Now I just need to simplify this. So I'm going to distribute the 2. 2 times 1/2 x will give me x. 2 times negative 4 gives me negative 8. And then I've got that plus 4 out to the right. If I combine like terms, I get x minus 4. So what I'm looking for is that both compositions equal x. This one equals x minus 4. Since I didn't get just an x, that means that these are not inverses. I don't even need to go and do g of f of x. A simple no will suffice as well. I'll know what you're talking about. So I don't even need to do this composition. Once one doesn't work out, you're good to go. Okay? All right. We're going to do the same thing here. So I'm going to start off by doing f of g of x. So that means I'm going to take the g of x, and I'm going to plug that into the f function. So I'm going to write that function down, but in place of the x right here, I'm going to put a parenthesis. And in that parenthesis, I'm going to put the g function, which is 2 square roots of x. Okay. Now, we want to simplify this. So the first thing I need to do is I need to square what's in my parentheses. So I'm going to leave the 1/4 out here. I have to square 2, so 2 squared gives me 4. And then if I square the square root of x, the square will cancel the square root out and I just get x. Then I need to multiply. 1/4 times 4 is 1. So 1 times x is just x. Okay? This is what I'm looking for. So if this one works, then I'm going to go and do g of f of x. So I'm going to go backwards. So this time, I'm going to plug the f function into the g. So instead of writing the f function, we're going to write the g function down. So that gives me 2 square roots of something. Remember, you're not going to put anything in for x yet. Once you get that written down, you're going to plug in the f function. So that means I'm going to plug in 1/4 x squared. Now what I want to do is I want to simplify. So I have 2. Now since you're just multiplying here, okay, if this were a minus in between, you can't split that. But since it's multiplying, I'm going to take the square root of 1/4, and I'm going to take the square root of x squared. So with a fraction, remember you have to square root the top, and you have to square root the bottom. Then you still have square root of x squared. So what I want to do is simplify. I've got 2 times square root of 1 is 1, square root of 4 is 2, times the square root of x squared, which is just x. So 2 times 1/2 is 1, and then times x. So again, I got just an x. This is what I'm looking for. If I do both compositions and I get an x for each one, then that means that yes, they are inverses. Okay? Alright, I have 2 more problems, I think, for this. So again, we're going to start off by doing f of g of x. If you want, you can do g of f of x first. It really doesn't matter as long as you do both if one of them works out. So I'm going to take and plug in the g function for the f. So I'm going to write down the f function, put a parenthesis where the x is, and in that parenthesis in place of the x, I'm going to plug in the g function. So that gives me square root of x minus 5. Alright, so I have to simplify this. Anytime you square a binomial, you actually have to sit there and multiply it by itself twice. Alright, so what I'm going to do is I'm going to FOIL this. So I have square root of x times square root of x is just x. Square root of x times negative 5 is negative 5 square roots of x. Negative 5 times square root of x is negative 5 square roots of x. And then I have negative 5 times negative 5 is 25. And then we don't want to forget that we also have this plus 5 at the back. I'm going to go ahead and write it here too. So if I combine like terms, that gives me x. Oh, I messed up right there. This one right here is supposed to be an x. Sorry about that. So then I've got negative 5 square roots of x minus 5 square roots of x is negative 10 square roots of x, and then you've got plus 30. So as you can see, you have no more like terms to put together. Okay, so I obviously did not just get an x, so therefore there's no reason to do the other composition. These are not inverses. Okay, and this last one. Going to do the composition. So first I'm going to start off with f of g of x. And that simply means I'm going to take g of x and I'm going to plug that in for x in the f function. So I'm going to write down the function of f, but instead of writing the x, I'm going to put a parenthesis in that spot. Now I'm going to fill in the parentheses with the function of g. So that's 3 over 2 times x minus 9. Now I just need to simplify. So 2/3 times 3/2 x is just x. 2/3 times -9. I know you guys have trouble with fractions. Okay, you have a positive times a negative, so it's obviously going to be negative. 3 goes into 9 3 times. 2 times 3 is 6. Also, if you just take your calculator, take 2/3 times -9, it's going to give you 6. Combine like terms, -6 and +6 cancel and leave me with just an x, and that's what I'm looking for. So now I'm going to do the other composition, g of f of x. You're going to take the f function and plug it into the g. So I'm going to write the g function down since that's the one I'm plugging into, but instead of writing an x, I'm going to put parentheses. Then I've got -9. In the parentheses, I'm going to put the f function. So 2/3 x plus 6. When I simplify, 3/2 times 2/3 x will give me x. 3/2 times 6. If you want, 2 goes into 6 3 times. 3 times 3 is 9. Again, if you have your calculator, you can just put that in and it will give you a fraction. Those cancel, and I just get an x. That's what I'm looking for. Both compositions equal x, so therefore I know that these are functions. Now, there are other ways to do these. Okay, so what I'm going to do is I'm going to go back to this first example that I did. Well, I'll tell you what, let's go to the second one. So you have your two functions, okay? And what I'm going to do is I am going to pull up the calculator. So I'm going to show you how to do these with a graph. You do have to show your work, but this is a good way for you to check and see if you're doing them correctly. So go to your y equals. If you have anything in there, clear it out. So you have two separate equations, okay? The first one is 1/4 x squared. So what we're going to do is we are going to put this one in your y1, okay? And then we're going to put the second one in your y2. Okay, so I've got 1/4 x squared. I'm going to go ahead and get my pretty print up here. So if I press alpha y equals, that's option number 1 there. I'm just going to press enter. And I've got 1/4, so 1 on top, and 4 on bottom. And then, I can't remember what my equation is, 1/4 x squared. So I've got x, I'm going to square that. So that's in my y1. In y2, you're going to put the other equation. Oh, click the wrong thing, sorry. 2 square roots of x. So I've got 2. I'm going to press second and the x squared button to get the square root, and x. So what I want to do is, if they mirror each other across the line y equals x, then that means that they are inverses. So in y3, I'm going to put my mirror in, and we've done this before. So put an x in, and then we're going to look at the graph. Now, y1 will graph first, y2 will graph second, and y3 will graph last. So what you're looking for is a mirror across this third line. So if I graph this, here comes my y1, and here comes my y2. Now, what I want you to notice, okay, is this makes a whole parabola. This one didn't because it's sideways. Therefore, I would need a plus or minus in front of my equation. But I'm just worried about the mirror across this line. Okay, I'm really not worried about this side. And I'll show you in a minute what that looks like if you put the other side in. But as you can see, this cuts right down the middle and makes a mirror between your red line and your blue line. Okay, if I go back to my y equals, well, I went back and now it's frozen. Okay, we'll leave that be. That makes a mirror, and that one was a yes. So I wanted to show you one that did make a mirror. If it doesn't make a mirror across that line, then it's not an inverse. So it's a good way to check yourself. Just in case you did some math wrong, you can see the picture of it, and you'll be able to tell. So if you need to, watch the video again, start it over. You can go back, pause, look at things, and if you have any questions, you can always come and ask me when you get back.